What's going on, everyone? In this video, we're going to take a look at how to find the inverse functions of cubic functions and how we can make sure that when we're graphing them, we are indeed looking at the inverse and how we can prove that they are symmetrical about that line y equals x. Let's take a look. All right, so our first task is to find the inverse of these functions. And if you remember, that basically when you're graphing the inverse, you're swapping those x and y coordinates, and one really easy way to find out what the inverse function is to literally swap the x and y in your function and then solve for y. So when I'm given f of x is equal to x cubed minus 2, let me just rewrite this as y is equal to x cubed minus 2, and let me go ahead and swap x and y. So I'll have x is equal to y cubed minus 2. Now when I solve for y, I'll be finding the inverse function. So let me go ahead and get 2 to the other side. I have y cubed. That means I'm going to be looking at the cubic root of x plus 2 equals y. And that is going to be my inverse function. I have y all by itself. Positive 1 is a coefficient, no powers. Cool. Now that I have my inverse function, let's go ahead and plot that against the original function. And let's just take a look at what we are seeing on the graph. So my blue graph is my original function, x cubed minus 2, and my red is my inverse function, the cubic root of x plus 2. And do these look like inverse functions? Well, of course, we're looking at that line y equals x. Does it look like it is kind of cutting these two in half? It's providing like a line of which they are symmetrical about, kind of a mirror image. And yes, it does. And you can see that my y-intercept on my blue function is 0, negative 2, which would make sense because when I flip that to be negative 2, 0, that is indeed on the inverse. That's my x-intercept there. And you can see that right at the point y equals x, I have 1.52, and 1.52 is the point of intersection. So yes, this indeed is the inverse function, and this is what it looks like when you are graphing them both at the same time. And if you were to draw this by hand from the graph, you would want to include these values as well. You'd want to include the x and y intercepts, the point of intersection, and maybe one or two more other points, so that way you can get the graph as accurate as possible. Now my second equation looks a little bit more complicated. I have 4 times the quantity of x plus 1 cubed plus 5. So same thing here. I want to get the inverse function, which means I'm going to swap my x and y to be x equals 4, and then I'm going to have, y plus 1 cubed plus 5. Now I'm just going to solve for y. So first things first, I'm going to move that 5 over. Then I'll be left here. Then I'll go ahead and divide each side by 4. Now that I have y plus 1 cubed, I need to take the cubic root of both sides to get rid of that. So I'll be left with the cubic root of x minus 5 over 4 equals y plus 1. Then I just got to subtract that 1. So I'll be left with the cubic root of x minus 5 all over 4 minus 1 equals y. Very important to realize that this right here is what I'm taking the cubic root of. So when I'm subtracting that 1 to get to the other side, it is outside of this cubic root. That's very, very important to remember. So now that I have my inverse function, let me go ahead and plot that against my original function. So my original one here, my inverse one here. And this is what it's going to look like, okay? So I already took a look at my original function, which is 4x, this pink one, 4x plus 1 cubed plus 5. I have an x-intercept at negative 2.08, and I have a y-intercept at 9. And again, if you switch those, you should find that they are on the other graph, which is my green one. And so my x-intercept goes from negative 2.08 on the pink to being my y-intercept on the green. Good. My y-intercept on the pink goes to be my x-intercept on the green. Yes. And it looks like it is reflecting about that line. And if you want to do the point of intersection on the line y equals x, the way that you do that, at least with the Ti-Nspire, is again, you'd hit menu, then you'd hit analyze graph, you'd get to the intersection. Now it's asking you which graphs you want to take the intersection of. So I would select the pink, and then I would select the green as my second graph, and then I go to the left and the right for my upper and lower bounds, and there it is. You'll find that it'll be negative 2.22 for both your x and y coordinate for that point of intersection. And that's what you'd want to include on your sketch, all those points that we just listed. So I hope that helped you out in terms of finding out what the inverse function is algebraically, and then how we can use our graphing technology and our calculators to figure out our main points of interest to help us sketch this out by hand as easy as possible. All right, so hope that helped, and I'll see you all in the next video.